Right, so what I'm going to be talking about today are two pieces of work that we've done. Actually, sorry, yeah, I should introduce myself first. So I'm Clare Rowland, I'm an Earth observation scientist and I work at CEH Lancaster, and I mainly work on land cover change. And today I'm going to be talking about two different pieces of work we've done. One mapping urban creep, so land cover change within a city environment, and then UK land cover change. So both bits of work are land cover change, but at two very different scales, one at the UK scale and one at Edinburgh scale. So I'm trying to work out how to advance this in the next slide now. Okay, so there's. Right, so I'm going to talk about the small scale land cover change work first. So this is some work we did a couple of years ago with CREW, the Centre of Expertise for Water in Scotland, and CEPA. CEPA have a responsibility for flood monitoring, modelling and monitoring and prevention in Scotland. And they were interested in how urban creep, how fast it might be happening, where it might be happening, and what kind of rates it was happening at in Scotland. So the previous estimates of urban creep had all been England based, and for quite small areas and for quite limited amounts of times. So what we wanted to do was to develop a method that we could use for a whole city scale, so for all of Edinburgh, and also to get some Scottish estimates. So we had aerial photography for 1990, 2005 and 2015. We were looking at a 96 kilometre squared area, so 8 kilometres by 12 kilometres. We had 10 centimetre resolution aerial photography, which was 90 gigabytes over the 3 years that we had. I'm not going to go into the method too much because I think it's better to focus on the results for this seminar series, but basically what we did was something called image classification. In image classification, you take either an aerial photo or, with most of the work I do, a satellite image. Then quite often you do some pre-processing. So in this case, what we did was we did some contrast enhancement to the aerial photography, and then we segmented the photography into areas that looked very similar. And then we applied an image classification. Image classification is where you identify areas of vegetation or urban areas. So you draw polygons around them, then you train an image classification algorithm. And you run that to produce your classification. So our final classifications for Edinburgh from the aerial photography mapped to vegetation areas, which you can see in the green, urban areas, and then shadow. We had to map shadow because if you look on the aerial photos here, you can see there's quite a lot of shadows cast by the houses, and we couldn't tell what was going on in those areas. So we had to mask those out of the 1990, 2005 and 2015 aerial photos because we basically couldn't do anything with that data. So from the 3 sets of aerial photography, we produced classifications for the 3 years. And then we looked at categorizing the changes we saw into urban creep. So urban creep is, if you look at this photo here, this is 1990, and you see there's quite a lot of grass in this garden. But by 2015, we've got some sheds here. They've paved over this area. They've paved over the front garden. So there's been a lot of urban creep around that property between 1990 to 2015. But we also had to map urban expansion. Urban expansion is where you get big new developments on greenfield sites. We weren't so interested in those, or CEPA weren't so interested in those, because they know where they are and they go through extensive planning procedures to make sure that they don't contribute to flooding. But we had to map where they are to take them out of our urban creep estimates. We also found areas where we had an urban decrease or urban regeneration. So if you look at this photo in 1990, you can see that this is some sort of industrial area. But by 2015, this had been redeveloped into flats. So you've got the new flats here, and then you've got this new area of vegetation within Edinburgh. So looking at the overall rates of change, what we found, I suppose, isn't surprising, that you get an increase in urban between 1990 and 2015. You get a decrease in vegetation. The amount of shadow stayed the same because of the way we masked it out of all 3 years. But it gets more interesting when we start to look at the type of change. So the black line here shows the total increase in urban area. The orange line shows urban creep. The grey line shows urban expansion. If you look from 1990 to 2005, the amount of urban creep and the amount of urban expansion are very similar. When we go from 2005 to 2015 though, the urban creep is actually much bigger, well, it's actually bigger than the amount of urban expansion. We also get a small amount of increase from urban roads, and then we also get our urban decrease or urban regeneration, which acts the opposite way. Because our data is spatial, we can map it across Edinburgh, so we can see where the big changes are. We can see where we're getting most of the urban creep. We can see where we're getting new roads. It doesn't show up very well, but you can see there's areas of urban decrease as well. That's what used to be Edinburgh Royal Infirmary in the centre of Edinburgh, and it's now been regenerated into really expensive housing apartments. You can also see areas of urban expansion kind of round the edge of Edinburgh as well. So we can look at the spatial pattern, but because it's spatial data, that then means we can analyse it with other spatial data sets as well. So we've got some data on the types of property across Edinburgh. So we know where the semi-detached properties are, the detached properties, the bungalows, the terraces and the flats. And so what we find is, I suppose unsurprisingly, that you don't get very much urban creep when you've got tall flats because there's no exterior space for them to expand into. You get most or the highest rates of urban creep when you looked at the semi-detached, detached and bungalow properties, because those are the ones typically that have the biggest gardens, so they've got the space to have urban creep. And just looking at kind of one section of one street, we can see what happens when you do have these large attached properties with large gardens, that they just have a lot of potential and that they have increased in size between 1990 to 2015. So you can see here that across these 4 houses, you've got a mix of conservatories, you've got housing extensions, you've got new parking spaces. So the trends that we see here are kind of also matched when we look at the aerial photography as well. So the key findings are that urban creep gave us about 7 hectares, increased by about 7 hectares per year across between 1990 and 2015. Now, if anybody saw the tweet, I promised I'd mention football pitches as a unit of area, so this is where I'm going to do it. So that's about 8.5 football pitches of vegetated land that is lost to paving over by urban creep every year. Whereas urban expansion is only about 6.5 football pitches a year. And in total, between the two things, urban creep and urban expansion, it means Edinburgh's losing about 15 football pitches of vegetated land each year. And we also find that it's spatially and temporally variable. So it was definitely useful to get Scottish specific estimates, but we don't know that the estimates for Edinburgh are relevant for any other Scottish city. We also found that the urban creep rates vary with property age and property structure, and that urban creep can be mapped from aerial photography. So from that, I'm going to jump to the other scale, which is the UK-wide work. So the UK level work that we do stems from the fact that CEH have been involved in land cover mapping since the early 1990s. So we originally produced Land Cover Map 1990 in the early 90s. The original Land Cover Map 1990 just covered Great Britain. We have, just before the summer, released a new version of Land Cover Map 1990, which covers all of the UK, and which uses the same classes as the land cover maps have since 2015 onwards. It also uses the same spatial structure as land cover maps from 2015 onwards. And this is important because this has allowed us to produce our first UK-wide change data set. We've still got, before the summer, we also released 3 other new land cover maps, Land Cover Map 2017, 2018 and 2019. We've still got 2 older style land cover maps in the land cover map family. So 2000 and 2007 still use different spatial structures and different sets of classes. So they can't be involved in any of the change work at the moment. So I'm just going to have a drink quickly. Right, so this example shows an area around Milton Keynes. So what we're looking at here is where it's white, there was no change. where it's coloured, there was some kind of change between 1990 and 2015. So if you look at these arable areas here, this is grassland, and if we click to what it becomes in 2015, we get this big increase in urban area. So it's in Milton Keynes. It's a new town. It's expanded rapidly between 1990 and 2015. So we see that in our data sets. We also see some new water bodies around here as well. So that's what the data looks like when you look at it as a high resolution. For most of the rest of the presentation, I'm going to focus on a more kind of summary level or kind of UK level stats. So we've produced net land cover change statistics for each of the devolved administrations and for GB and UK. We've also got some fancy infographics. At the moment, they're GB level because we didn't have the Northern Ireland data ready to go when we needed the statistics for the infographics. But they stand quite well for the UK level stuff. And basically what we see is we see an increase in woodland and an increase in urban area. And that's at the expense of arable and predominantly grassland. Again, because our data is spatial, we can look at it spatially. So what this shows is the spatial trends. So this is at county level, and we're looking at a map of net grassland change here. Sorry, some of this has gone off the slide slightly. So the key thing we see with grassland is this big reduction by almost 2 million acres between 1990 and 2015. And to put it in some context, I haven't looked at how many football pitches it is, but it's an area greater than the size of Suffolk and Sussex combined. So I'm sure that must be lots of football pitches. For grassland, we get a mix of increases and decreases at county level. The biggest increases are in Northern Ireland, but we also see some increases in Norfolk and a couple of other counties as well. If we look at woodland, again, there's been a big increase in woodland between 1990 and 2015 of over 5,000 kilometres, which is about the size of Norfolk. This has been mainly in Scotland. The biggest increases in Argyll and Bute, where there's over 600 kilometres squared of grassland. The numbers are probably a little bit too small for you to see kind of clearly on this slide, so I'll have to sort that out for future presentations. But the big trend is that the increase in woodland has been in Scotland predominantly. This shows the spatial trends in arable. It's not an ideal legend at the moment, and I didn't realise until just before the presentation that I hadn't put this slide in, so I had to put it in hurriedly. But what we see with arable is a mix of increases and decreases at county level. That's not very clear from this legend because you can't see where it's increased and decreased very well. But the biggest increases have been in southwest England. One of the things that we do see is this big churn between grassland and arable, just as part of the general farming rotations. But this increase in arable towards the southwest seems to be part of a bigger trend and not part of that normal grassland arable rotation effect that you see. We also saw an increase in water. It's a lot smaller than the increase in woodland. So just linking back to the other work, it's an area, we've got a net, so that should be a net increase of 150 kilometres squared, which is an area about 1.5 times the size of Edinburgh to link into the Edinburgh work. The largest increases are in England, the Midlands and Eastern England. And quite a lot of these changes are around the new towns like Milton Keynes that we looked at earlier, but also Swindon and Peterborough, where you have old gravel extraction quarries that have then become recreational lakes. We also looked at urbanisation is a big trend over the last between 1990 to 2015, both at the UK level and also at the Edinburgh level or the individual city level. The biggest increases were in Kent and Essex, and then also West Yorkshire. And the total increase in urban was an area about the size of Cornwall. This slide shows a Sankey diagram, and we can start to look at the flows. So where we got the increase, but where that land has come from. So if you look at this big grassland chunk here, this is what, sorry, I should explain this better. On the left, what we have is the stock we had in 1990. On the right is the stock that we've got in 2015. So if you look at the grassland bit here, we've got this chunk here that turns from grassland to woodland. We've got this kind of slice here that goes from grassland and becomes arable. And we've also got this slice, which is much harder to see, that goes from grassland to built up. So this just lets us see what the flows are between the different land cover types and where the losses are and where the gains and where they're coming from. So just to summarise what we've seen there, we've seen a major loss of grassland at UK and city level over the last 25 years. The grassland loss fuels the increases in woodland and urban land cover that we see. And urbanisation happens at very different scales. So we're seeing it at the UK level, but we also see it at the individual city level. And where are we taking this work in the future? Well, we've got the land cover map family now. So we've got the land cover data sets, we've got the land cover change data set. In the future, we're going to be adding more time points into the land cover map series so that we'll have then better resolved change data. But we're also going to be starting to produce some continuous products as well. The first of which is going to be a grassland net primary productivity data set, which should have data for 1990, 1998 and 2007, which we should be releasing that sometime in the autumn. So the intention basically is to build up the range of spatial data sets that characterise land cover and land cover change for the UK. So any questions?